Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
and inspire you to do even greater things.
Before we jump into today's conversation, a special thanks to PM Power Consulting for encouraging and supporting this show right from the start. With over 1,000 person years of collective experience, PM Power has helped many organizations, teams, and individuals chart out their own journeys of excellence and make progress. Thank you, PM Power. My guest today is Thanos Diacakis, who's a software delivery coach and a fractional CTO. We covered a wide range of topics that included his insightful experiences on software delivery lifecycle and how that can be improved without using jargon and terms like Kanban, etc. We also spoke about balancing work and personal life and a little more deeper dive into the fractional CTO business. But what are the benefits of having a fractional CTO? And how, as a fractional CTO, one could manage time. And finally, we also talk about learning from others, the value of learning from others and how you can learn and what you can learn from others. A lot of good tips. Listen on. Hi, Thanos. Welcome to the Software People Stories.
Thank you. Glad to be here.
Yeah, I was very curious when I first got your reference and saw that you're a software delivery coach, and that's a title that we have for the first time on the show, and a fractional CTO. Okay, I can probably envision a lot of the challenges or curiosity questions, but before I get to that, we'll start with your origin story. What you've been doing, how you got into software, IT solutions, and your career trajectory, and we'll take it from there.
Yeah, I started software really young. I was kind of fascinated by programming from a very young age. I think I was writing BASIC when I was 5 years old. And I think you have the classic young kid story that was really into computers. So I went on to study it in university in England. I was born and raised in Greece. And then I went on to grad school in the US at Carnegie Mellon. And the fun part of the story starts around then. Because we did this entrepreneurship project at Carnegie Mellon, and that ended up turning into an actual company. So my first job out of college was a startup of my own, and that was back in the dot-com era. So we sold that right after the bust. So that was kind of some interesting times back there. And I went on to do various startups in various roles as a software engineer. Sometimes I'd act as the lead software engineer and called that VP of engineering, though I had no idea about managing at the time. Like managing people was in my title and in my job description, but I was probably very, very bad at it. But over the years, by doing all these startups, I got kind of a broad perspective about the different aspects of delivering software. That was end to end, not just writing it, but what does it take to product manage it, and what does it take to design it, and what does it take to ship it, and what does it take to make money out of it, and what does it take to raise money to get in a situation to be able to do this all together. So that was quite fun. I spent a few years working for a large company in the mobile space in the early aughts. And I did a bunch more of the consulting, startups, advisor to startups. And then in the last decade or so, I spent a few years working for the big companies. I spent 3 years working for Uber for their bikes and scooters project. And that was kind of fun because I was always like a small startup guy, and I don't think Uber knew exactly what to do with me when I joined them. So they made up a title for me, and I ended up being the lead on the back end for the bikes and scooters project. I don't know if you caught wind of that, but they put electric bikes and electric scooters in a lot of cities around the world. Yeah, so we scaled that from nothing to like 45,000 vehicles and like 2+ million rides every month. So that was a lot of fun, and seeing and learning from others as to how this is done in the bigger companies. And then I spent 3 or 4 years at another health technology startup, big company called Included Health. And one of the things that where my epiphany came in all this origin story was that all the companies that I've been to struggle with software delivery. They have trouble getting their software out. They may be really good, they may know a domain, they may know a field, their engineers are smart people, but the common pattern all across is that they struggle getting the software out the door. So I figured out, why don't I make a title like software delivery coach and start pitching that and turning that into a business. So instead of helping one company with their software delivery issues, as I was doing as a senior staff engineer or whatnot, I can be helping multiple clients with this. And it's this quite specialized stuff that one does to get software out the door. So that was that. I also pitch it as a fractional CTO. I think the software delivery coach is not everyone's cup of tea, right? Some people have trouble getting their head around that you need a coach for your software org. So they would like to hire a CTO that more or less does the same thing in a slightly different model. So I kind of use both of these as I just talk about it. It resonates differently with different people. But the role is largely overlapping. It's very much your focus is, how do you get a startup or an existing business whose value is delivered through software to be effective at getting that software out the door.
Hmm. Yeah, wonderful. I think there's a lot to unpack there. I'm curious, what program did you write first when you were 5 years old in BASIC?
Oh, I think it was the 10 print hello and then 20 go to 10 kind of words. It was I think it was kind of silly stuff. It was back in the days where you'd get programs from magazines and you'd type them in and you'd see what they do. So I like to sort of tinker with those sort of things. I also, I think, sort of solved some of my school problems using the computer, which was not acceptable as an answer, but it was fascinating to sort of learn the internal mechanics of that. And one thing that I did as a kid is I was into electronics and also like into assembly language. So I have the odd distinction of knowing how this works all the way down to the little bits and bytes.
Uh-huh.
And that has turned out to be interesting in some cases, right? You could be debugging some fairly sophisticated large system, but this may be failing in some fairly narrow, all the way down to the bits computer sciencey thing. And I think by understanding that, you kind of sometimes you have a leg up. I've seen younger engineers that learn how to program in college in the age of sort of Java, and you tell them what a pointer is, and their eyes glaze over, and it's like, oh, what is that, right? And again, that's not necessarily bad, right? I don't want to have to handle pointers in my everyday life. They're dangerous and mostly result in bad things. But it's interesting how having a fairly broad perspective across the stack and across like in many dimensions of the engineering process gives you insights that are actually helpful in the day-to-day of companies.
Yeah, I mean, not in any negative sense, like to classify a developer as either a keyboard developer or a mouse developer. You just drag, drop, compose some things, or you go down to, may not be assembly language, but at least go down deeper and know how things work. Yeah, how the
Yeah,
program
that's always fun. But I didn't answer your question because I think that the first really meaningful software that I wrote was a neighbor was running a greenhouse, and they were selling, I think it was iceberg lettuce to the local McDonald's in Greece, and that must have been about 15 or 16 at the time, and they needed help sort of managing the incoming orders and the inventory and all that stuff. So I wrote some kind of software it was, I think, it was IBM PC compatible machines back then. It was some kind of command line software that would help manage the incoming and the outgoing, and that was my first my first actual gig. I don't think I got paid for that, but it was fun anyway.
Yeah. And also found it interesting that right after school or even in school, you said you had a project and then that kind of turned into a company, right? So
Yeah,
how
I
did you
always
go
had
about,
the
yeah, how did you go about identifying what problem to solve?
So this started off in an entrepreneurship class, and part of the entrepreneurship class was how to identify what problem to solve. So we kind of, we kind of had a technology looking for a solution, and then we tried to then take this technology and find different parts of the market that might be right for the solution, and then start from there. So the particular technology that we had developed, this was in the late 90s. I remember there was like the ICQ and AOL and MSN instant messaging wars. So what we'd done is we had developed a distributed system for messaging and presence. So presence is like that status that is now
Mm.
everywhere where you can see if the other person's online. And that had the publish and subscribe mechanism wasn't as widespread back then, where multiple sources could subscribe to one source of information and you could funnel that out. So we had built a fairly nice distributed system that did this, that was resilient. You can yank the plug out of one machine and the rest would shift the load around. And we thought, what could we do with this? And what we did is we pitched it to the mobile carriers. So we thought like the software companies, AOL and ICQ and Microsoft at the time were leading it on the desktop world, but the mobile carriers really wanted to get in that market. So we pitched it to them and we ended up working out with Motorola, which was making phones back in the day, and get that embedded in their phones and try and compete with everyone else. And we got in the standards world and work with interoperability and try to get standards that would have all these systems work across. That really never happened. That's a long, different, painful story. But that was the genesis of that project.
Oh, interesting. By the way, my phone right now is also a Motorola phone.
Nice.
Yeah. Okay. Even though the ownership has changed. Yeah.
Yeah, and I think their business model has changed a fair amount, and everything is now on Android. But back then, everyone was trying to make their own software, and everyone thought they were really good at it. And I was working for a company, the company that acquired us was OpenWave, which was one of the few vendors at the time that was trying to be the independent software vendor for mobile carriers. So they would sell email servers and software that would go on the phones eventually for those guys. So that was interesting times before iPhone.
So when you got into these startups, or you wanted to start on a problem, how do you draw the line to say that I'm ready to go to the users?
You mean when something is ready to be shipped to the end user?
Yeah.
Yeah, so that's interesting. I just saw a little post on LinkedIn yesterday that was talking about the sort of waterfall and the agile ways of doing this.
Mhm.
And back when I started in the early 2000s, that wasn't like a solved idea, right? People were still struggling with what is the right cadence of shipping software and what is an MVP. And if you recall, they were making these releases that would take 6 months or 9 months or a year or multi-years sometimes before they actually ship something. And the agile environment was coming up, and extreme programming and all those buzzwords at the time. They were saying, no, 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 you throw all these things away and you do these weird meetings where you all do this standing up. And I think back then that those were sort of fresh ideas, and we're trying to see how do we take these ideas and combine them with how we do things. And businesses weren't quite ready to be told, hey, you're going to be shipping code like every week or every 2 weeks. And it wasn't very clear how the users would kind of take this information and include it. And sometimes the software was sold on CD, so you have to actually ship something to someone. So I think my view on this has obviously changed over time as we learned this. But the analogy that I was talking about that I saw on LinkedIn was the idea where you have like the waterfall is where you have a wheel and then you have an axle and then you have a frame and then you have a car, right? Where none of these are usable until you have the end result. Whereas the agile is you have like a unicycle, and then you have a scooter, and then you have a bicycle, and then you have a motorcycle, and then you have a car, where every little piece of these are usable. So as my own mindset has been developing on this is you want to have something that adds value to the user, right? Like if the user cannot take what you want to ship to them and use it in a meaningful way, don't ship it. It can have some rough edges, and it depends on your user, right? You have to know who your user is. Some users may be willing to take something that is way less ready than others, but at the end of the day, it has to do something for them. And I don't think you can express this in sort of like one hard and fast rule, but there's some smells, right? If you ship too often, right, is the user now confused? Like I can't handle these releases every day because I don't know what's happening. So maybe you could still release it every day, but you could tell them about what's changing once a week, right? So then there's like a nice cadence where they can learn the software anew. If the user is like chomping at the bit for new features and you're not giving to them, well, maybe then you're releasing too slowly. Another common thing that happens when you do this is you get to MVPs and you ship a bunch of MVPs, the minimum viable products, but then you never go back to like clean it up and make it a grown-up product. So you have a bunch of kind of minimum viable, but they're not that great. So they're good, but not great. So a lot of companies struggle with, okay, well, how many MVPs do I ship? And then I kind of go back and sort of clean it up a little bit. And those are hard judgments to make at times, right? Because you can look at um, adding new features may give you new revenue, new clients, new value, new customer satisfaction. But then if you don't maintain them and clean them up over time, that might lower your overall long-term retention. So my usual advice to this is companies have to sort of experiment and find their balance of where this is, right? You got to ship enough new features that you feel you're growing at a pace that you're happy with, but also you do have to go back and clean this thing up. And all these things kind of depend on what the phase that you're in, right? If you're in a startup, you might be geared a lot more towards shipping new features than going back and cleaning them up and fixing them. But then if you're a company that is much more mature and has a stable customer base and those customers are not used to it and they want more stuff, you may dial this back and be a little less shooting new features all the time, but also going back and fixing and making sure that everyone's sort of taken care of and your retention rates don't go down. But it's always a fairly subjective judgment. There's no, as with all software stuff, what you'll usually hear me say is, I'll give you principles and mental models and ways to think about this. Then you have to apply this to your situation. It's impossible to just make a rubber stamp and say, okay, if you check these three flags, then go do this.
Yeah, so that is what I was trying to understand. When you start up, probably there are a lot of ideas, but then there's also this need to ship. Plus, it's not only the software that you ship, but you also probably have a team or others who are expecting you to go get the business. So how do you manage all these things?
Well, you have to figure out what's important at any one point in time, and that sort of drives you. So if you're a startup, maybe what you need is to build your first thing. Maybe what you need is to have your first revenue, maybe to have your first customers, right? So work out what your North Star is, work out what success looks like 6 months from now, and then work backwards from that, from what needs to fall in place to get there. Keep it in mind. One of the mental models that I talk about is bottlenecks. So the concept behind bottlenecks is fairly straightforward. Is let's say you have a factory that makes widgets, right? And there's one of the machines that in some stage of the process that is slower than the others. So that's going to be your bottleneck. So if you go fix stuff beforehand, you're going to pile all the work on that machine, and you're not going to go any faster. Like the output that goes out on the shipping dock is still going to be exactly the same. Similarly, if you're on the right-hand side of that machine and you fix the machines that process stuff afterwards, they're going to be starved for work. They have nothing to do until you fix the bottleneck. And typically, unless things are extremely even, which is very, very rare in software, you can have one bottleneck. There's one thing in your whole process that is controlling what you do. So you go protect this bottleneck. This is coming from Eliyahu Goldratt, Constraints Theory. I don't know if you've read those fascinating books about lean manufacturing. But you find the bottleneck, you protect the bottleneck, make sure the bottleneck is taken care of, it's happy, it's fed. You put a bunch of rules to make sure no one stops your bottleneck from working. And eventually you sort of fix the bottleneck, right? You might add capacity to that machine, and then the bottleneck shifts. So now something else is the problem. So in a similar way, bring this back to the startups. Your first problem that you may have, your first startup bottleneck may be to finding your first customer. So you might organize a lot of activities around that and protect it and get really good at doing that. But keep in mind that once you get that one, now your bottleneck is something else. Now your bottleneck is like, say, scaling. So now you need to throw away all the rules you made because they may not be helping you anymore and go focus on the next problem. So the point here is that things change around. Like, don't get too happy in the one spot you've been and now we're getting good at this. Things are always going to be changed. They say death in taxes, but it's death change in taxes in my mind. That is a constant thing in this world. So I usually will try to figure out, okay, what is my end thing? What do I want to get to? What is my end result? And that was to be a results-based thing, not an activity-based thing. So it's not like I want to be spinning in my thing and writing software very efficiently. It's like, do I want to be shipping software to someone that is paying me for it? And then working backwards from that, what do I need to do? Where are my bottlenecks? And then figuring out how to solve these and make those faster and go from there.
Yeah, so now we are probably going beyond just the software part because this whole thing requires a team to work. And as a CTO, you probably need to also manage the dynamics of different teams. How do you go about that?
Yeah, so the fact that you need a team is actually an excellent point that you bring up, because if you focus on one thing, like I know you focus on the bottleneck, but the bottleneck isn't solved by one team or one group or one thing, right? It's solved by a variety of things, and those all have to play nicely with each other. So it is usually a fallacy to make one team really efficient because the overall system has more than one teams that play across that. The example that I like to give with software is you typically end up, because you want to have every team be busy and doing stuff, you end up with a pipeline model. So maybe you have, like, if you're like a mature company, maybe you have like a user research team and they figure out we want to work on this feature or this problem. So they create some specifications, shoot it over to like a product manager. They kind of like take it some more, maybe they write a product requirements document. Then they send it to a designer that like builds some screens and they ship it over to engineering and they kind of go build it and they ship it over to some QA team that tests it. And then maybe if you're unlucky enough, you have a special operations team that ship it, right? I'm making up an example that has too many steps. You could have 3 steps, you can have 10 steps, it doesn't really matter. But the point is, by the time the nth step is shipping, the first step is now working on end projects ahead, right? And this sounds good because everyone is busy, right? Everyone is doing their thing and running in their little mouse wheel and shipping things to the next part. But think about what happens when a bug comes up at the end. Now that has to, jump through and go and stick itself somewhere in the middle. And that will start now creating gaps because as someone shifted over to do work on this thing that you brought them back to, now the pipeline is emptying out and the people are going to be starved for work in between. And think of this as now bugs like flipping back and like user feedback coming in. This pipeline ends up being a mess and no one ends up working too efficiently. And the end result of shipping isn't usually affected, right? Because if you think of like what comes out the far right-hand side of this pipeline, it's going to have lots of gaps in between because people are shifting context all the time. They're going to make mistakes because like, oh, I worked on this like 6 weeks ago. How did this code work? Oh, I think this fixes it, and it doesn't. So what I will usually advocate is to get rid of this pipeline model and just have small independent teams that can deliver value. There's a book about team topologies. I don't know if you're familiar with that one, but it talks about the different kinds of teams. But one of the teams is like a stream-aligned team, and they basically can deliver value to the client independently of all other teams. So you kind of want to have these cross-functional teams that can take a problem, solve it. They can all be in the same locality, whether it's a room or a virtual room or a time space, however you want to organize it, but they can work together and they have all the decision-making capabilities to make their own decisions. So if a question comes up, someone can stick their head up in a Zoom, in a Slack, in a chat, in a room, and say, I need to know the answer to this. And if they can get it, they can keep moving. If they don't, then someone else can jump in and help them working. People get scared of this because, hey, the designer may be sitting around there not doing much while this thing is getting coded is the problem. Like, so I'm paying this designer, what's the point? And my answer to this is your value comes from shipping this. So if the designer is available when the design question comes up and you can answer it and ship it sooner, that is a massive gains to your business because you're not going to have these gaps in shipping, which is a massive opportunity cost there. Also, the value of that designer being able to see what the software engineer is doing as they're doing it and put feedback in sooner rather than later is also going to shorten your cycle times and you can ship a lot faster than you could. So it sounds a little sometimes counterintuitive because your local efficiency of that team may be a bit lower, but your global efficiency as a company is going to be much, much higher as you're getting value at the door at a much higher pace. So again, the advice there is you have to connect these cross-functional teams that work on a project base, however you want to make it, to ship stuff. There is not much point having all these silos and then making them play nice with each other if what you get is sort of this pipeline model that jumps across.
Yeah. So somewhat related to this, when people talk about either a T-shaped developer or a full stack developer. You have any good or bad experiences either or preferences?
Yeah, I love full stack developers. And I know they're hard to find, but I think the idea that you have the back end developer and the front end developer just creates pipelines of a different kind, right? You create a pipeline of I'm going to write, I'll write an API stub and I'll give the API stub to you and you write the front end and then I'll fill in the API while you do this. And there's a lot of mistakes that happen in that way. I think for me, engineering is engineering, right? Good engineering is understanding how the computer systems work and being able to build the whole thing. I'm not like super in love, and I know this is very common, but I'm not in love with the specializations where you have a front-end engineer that is good at just writing front ends but doesn't understand how the back ends work, right? Because they will be affected, right? They need to understand, am I like fetching data? Am I streaming data? Am I pulling data? Why is it hard to do some of these things? What are the back end considerations to do that? And having those people interfaces where you have to literally go and talk to someone and cross the chasm, and that person may be in a meeting or maybe sick or maybe working on a different schedule makes it a lot harder to ship. So if you're able to find or train these full stack engineers, the people that can do more and understand the end-to-end stack, for me, that ends up having much better results. This is back to what I was saying, like, I understand assembly language and I can get like really deep into a problem and sort of figure it out. That is super helpful because me trying to find the time to find that specialist is going to be a lot of cost for the business overall. Now that said, if you do have the front end and the back end, there's ways to fix that, right? Put them in a room, make them work together at the same time, put them in a Zoom. Find out processes like doing like the stub APIs first and then unlocking them so they can both work together. There's ways to manage that if that is your situation. Not all is lost. But if you can swing to get everyone to understand both ends, that's usually much, much more helpful.
So in this context, I'd like to go back to something that you said about learning from others. Are there any stories you want to share about something that either you learned the hard way, then found out by asking somebody, or taking help would have been easier, or drawing inspiration from something totally unconnected?
Yeah. So my experience from learning from others came when I first went to work for Uber, because what had happened is that before that, I had mostly done a lot of startups and worked with small companies, and I was usually like the most senior person there. So I was the one that was, I was kind of like going and learning from like actual other sources. And back then there wasn't that wealth of information that we have now, where you have like Slack with experienced people that you go to ask. We didn't have AIs. Stack Overflow was barely a thing. And my eye-opening thing was when I went to work for Uber, there was a lot more smart people than I was used to before. So, in the hundreds, right? So whereas before I kind of like was the person that was giving advice, now there was a bunch of people you go to and say, "Hey, how do we do this? Hey, how do we do that?" And you can see sort of the amalgamated information that had come from all these smart people into systems that the company was using. And sort of that was eye-opening. I learned in the 6 years I worked for the big companies, at the end of the last decade and the beginning of this one, there's a lot of new things that I learned. And I'm a person that loves kind of learning new stuff. So I just like a sponge, just bring it in. So since then, I try to be a lot more explicit with how I do my learning, right? So do I have like certain Slacks that have really smart people and I go on and read them, or I pick certain topics and I go pick up some books, or I'll call up someone that knows a specific subject and I'll go talk to them and figure out how to learn this. And by the way, my good friend TJ has this interview question that he uses that I've picked up since then, and it's you ask an interviewee, how do you learn? How do you learn new things? And you want to see, do they read books? Do they go magazines? Do they have like a planned way of learning things, or do they just wing it? And I'll use this inspiration to give you another little sidetrack here, that is interesting.
So about learning from others, particularly when you're trying to solve a problem for a user and in a startup kind of a mode, one, you don't have too much time, but at the same time, probably using metaphors, analogies, or trying to bring some other ideas which have not been in that domain. We've seen a lot of such stories where we've had these moments of inspirations. So are there any techniques that you follow to kind of achieve breakthrough ideas?
Yeah, a technique that I heard of recently, it was by Professor Osterhout. I think he's out in Berkeley. He was talking about the first idea that comes into your head is not always the best idea. The example that he was giving was that a lot of people that got to like the Stanfords and Berkeleys of this world were really good and top of their class, and usually the first thing that come in their head was good enough to carry them through whatever. But when they arrive at these universities with really smart people, then the first thing that comes in their head isn't necessarily the best. So I've been trying this technique out, and it's actually really great. Which is usually, you look at a problem and something pops in your head, and you're like, that looks great. Like I'll go do this. So now I will take a breath, pause, go back and go like, okay, that's one way of doing it. Let me come up with three more. And there's no lack of ways nowadays that you can get three more ideas, right? You can call like, a number of colleagues and going, I'm thinking of this. What other ways of this are good in doing? You can just pull up ChatGPT or Claude, and they will give you 10 different ways of doing this. Now, again, most of them are not going to be great, but a lot of times you'll find that even from those not great ideas, you'll see like a little thread, and you'll see something that's like, okay, this idea is terrible, but like that little thing in there is interesting. Let me play with that. And you grab a few of these, and you can then take your ideas and refine them. And for me, that gives me a bit more of a process than, okay, like the first thing that popped in my head because of my, how neurons work, right? My experiences and my past pop this in my head. But now let's add another layer to it. Let's like take it and refine it a bit further. Let's go talk to people and see how that lands. And that usually gets pretty good results. I usually come up with something much better than before.
So if you consult multiple people, you might be getting some very diverse ideas. So how do you synthesize them, or how do you pick the ones that are most relevant for you?
So I'll go back to like there's a set of principles that I have, and again, those are not like super fixed. I mean, they're pretty fixed, but they're fluid. Um, but as you work with different clients, what's really nice is that you can take these ideas, you synthesize them, we'll go into how in a second, but you can then cross-pollinate them, which is really great. So you can see, hey, this client did this, and we learned this from experience, and you can go feed this into a bunch of other clients. By the way, that's sort of really nice as a model because if you hire like a CTO or a VP of engineering for a role, they come up with like a fairly fixed set of experiences, and they might be with you for 2, 3, 5 years. They're drawing mostly from your company, whereas adding a coach to this then gives you a much more diverse set of stuff that you can pick from and learn in these ways. So that's a lot of fun. But to your question of how do you synthesize them, I think is you take principles and apply the principles to these ideas, right? So you come up and say, hey, we tried this new technique and it was working. And then I'll take this technique and I'll go like, okay, well, this works with this principle, right? It's in line with this principle. So for example, let's just take something that's fairly common, like you want to add automated tests. Let's say that was a new idea that came from somewhere. It's not a new idea. But then I put it against my stuff and go like, okay, automated test, puts more responsibility to the developer for fixing their own stuff. That's the ownership principle. That works quite well. I like this. Um, but it might not align with some other principle. And then you go back and say, okay, it doesn't align with this. Why does it not align with this? Is it a bad principle? Does it not apply? Is there something else that sort of overrides it? And you kind of think it through and apply it and see how you want to take it. Do you want to take it wholesale? Do you want to adapt it a little bit and put it back in your memory bank of things you use? Or do you want to throw it away and go like, yeah, I'm gonna not necessarily do this. This might fit here. I'm generally pretty open-ended. I think while I'm strongly opinionated on certain things being better than others, um, it's also acknowledged as very contextual, right? So something that I say, there's no way I would ever do X. And then you go work with the client, and it's like, yeah, in your situation, I'd probably go do X. Like, I maybe do it only for like a short period of time until you've solved Y. But this probably makes sense to do over here because you're in this kind of situation. But working with many different clients is a lot of fun. There's a lot of interesting things that you can get to um, synthesized together. And I find it very satisfying to be able to sort of then apply this across the board. It's really nice when something comes up with one client and you can feed to another saying, you don't have to rethink this because I've done this for you. We already did this for 6 months over this client. These are the interesting points to consider. Go knock yourself out. This is going to be good for you.
So that's really good for the clients. But for you, how does this task or context switching work?
It's rough. It's I won't lie, it's a big challenge and it's a big it's quite different from the mode of you work for one employer. You get up, you go to work at 8, you do your day, you turn it off or you go on call or whatever, and you have to focus on one thing. Um, I have 3 or 4 clients right now, and so you may be working on more or less every day. You'll work a little bit on every client that I have. And what I try to do is allocate some blocks. So I know, okay, this chunk of time I'm going to be working on this problem. So my mind kind of goes in one place and move it around. The other trick is to find sort of like little gaps, either like 20 minutes between meetings or something like that, to just knock out some easy tasks. Doesn't matter which client it is, but things that will not take your focus away later, right? So if you had any other interrupt-driven things, you go handle them in these little small gaps and try to create space for you to make that thought. So I found scheduling to be super, super important. In the beginning, I sort of struggled with this because you work on one client and like, I really want to finish this. And then you end up working all day on it and you neglect the other 3. So then the next day you pick the next one and whatever you're working on right now is where you get the most dopamine hits from like finishing something.
Yeah.
So while I really super into finishing something, I now try to be appropriately ambitious for the time slot that I have. So if I have a 4-hour slot to work on this project, I'll pick something that I know I can finish. So I get the satisfaction that I'm done. The client gets the value that this is done. And then my head is not still at it when I'm shifted over and working at something else. As that is a distraction. When you work for one employer and you're in the shower, you're thinking about the problems of that one employer. When you're working for like 4 or 5, your mind just tends to wander and you got to like bring it back and focused. And good notes. I always like as I get older, like I don't remember things as clearly as before, so I will often like leave notes for myself. Oh, okay, this is where I left this project, and then you go back to it, and it's like, oh, this is where I was, and it's easier to just pick it back up and go.
Yeah, for instance, when you mentioned your experience with Uber with the scooters and bikes, the thought of scaling, when do you have to take that into account?
From
That
very early
process.
on.
Yeah.
Yeah, so that project, Uber is one of these companies that scales tremendously. So anything that they do not cut corners, they just go at it. So even when we started bikes, we had very few bikes, but the plan for scaling was super ambitious. So I'll tell you a funny story that we had with this in terms of scaling. This was a performance review, not performance review, it was a promotions day. So Uber had committees that go over and do promotions. So I was in one of these committees, and we just started. It was like eight something in the morning, and which is commute time for bicycles and scooters. And I get a pager alert that goes off like system down. So we go look at it, and the main message passing system in there just completely crapped out. It just folded. It was gone. So now you have 50,000 bikes in the field that are just sending messages to a thing that is not coming up. And we had grown from like something small to that number in a fairly short period of time. So not all the controls were necessarily in place. So we figure out what is happening, and we fix it. So we boot the thing back in, and as soon as we booted the thing back in, 50,000 bikes go, hello, and the thing just craps out again. And you got one ear in the promotions committee and you one ear in your laptop on the outside of the room trying to fix this. So this is an example of where we had like there's systems that deal with this, right? There's load shut-off systems where you can cut off the load in one place, bring in the systems, bring them back up, and then turn the load back on. And instead of having like, just a little bit of the capacity built up and then it gets crashed as soon as you turn the bikes on, you can sort of build it over time. But we didn't have any of the systems in place. So we had to improvise and say, okay, what can we do to make the situation better? And I think we pushed some update to the bikes that said, okay, when you retry, just back off randomly, which is again another very common pattern to do this. And then when we turn it back on, the bike sort of came in slowly, or something along those lines. But that was one of the fun things of you kind of, we had an outage. It lasted for a few hours. Would it have been better to delay, scaling to that level until we put all these capabilities in? Or would it be better to just, deliver the customer value sooner, take a 4-hour outage in the middle of a Monday and then develop that capability in a hurry? So that's some of the fun challenges that startups have to deal with, right? How good do I break it? If you remember Twitter back in the day, they had the whale tail like all darn time.
Mhm.
But I was okay, right? They end up being in a good spot at the end because, early consumers had different expectations from late on consumers. Uh,
So working with different clients, like we spoke about a little earlier, do you see any common recurring challenges or patterns of challenges that come up in software delivery?
very much so. So I quip that there is, I don't know, 30 or 40 or 50 things that any software team needs to be doing to be good at any one point in time. And every company that I go to has about half of these in place, but it's never the same half. So everyone has some in place, but it's never the same. And I think the reason why this happens is that most software engineers, they don't get trained on how to deliver software in college. They learn about algorithms and systems and operating systems and other techniques. But they go to work for the first company, and whatever they do Scrum and Agile. Well, that's what they think software engineering is about. And then they go to their second company and they teach them that. And they maybe learn something from that one, and they kind of evolve in that way. But no one likes to focus on this aspect necessarily, right? They want to ship features for their users. They want to do other things. And companies don't do this, by the way, because they're dumb, right? Some of the people that I've been are the smartest people that I know. They're just busy, right? So if you have to deliver some stuff, for a customer, you don't want to take a step back and think of how is our software process working? Is the right culture that we have for this? You just get caught into this and you do the same pattern over and over again. So the few of the very, very common things that I see is technical debt. So you and I know what technical debt is, but I think the interface between business and software does not usually recognize what this pattern is. Maybe they've heard the word technical debt, but I think most of the times, a lot of places that I've been at, the business thinks of software of how they get features. So they think that they only ask of features to come out of the software engineering team. And that has an interesting side effect because it trains a software team to only respond to features. They think that business only cares for features. So there's other kinds of work that they need to do that they never prioritize. And I don't know if you know the flow framework, but the flow framework says there's four types of work. There's features, there's defects or bugs, there's technical debt. I like to call this investments, things that make you go faster if you invest in the future. And there's risk, like audit, updating your packages, and those things. So I'd like to have the business understand a bit more that there's four kinds of work, not one kind of work that software does, and that they need to talk about the other kinds of work and give space to the team to do these other kinds of work. Because if you only ever award your software team for building features, they're not going to care about technical debt. They're just going to know that where the bonuses come from and where their recognitions come from as features, and they're going to shoot themselves in the foot by not doing this other kinds of work that is absolutely necessary. This will vary, right? And you need to recognize that if you're a startup, you might be doing 90% features and 10% everything else. But if you're a mature company, it's not uncommon to be 30% features, 30% bugs, 30% investments, and 10% risk management. So that's one of the most common ones. The other most common one that I see is that the teams are super overloaded. And that creates a lot of context switching. So I'm doing 10 things at once. I got to switch between them. Everyone's just yelling at me to get things done. And I'm going to produce a lot of bugs because I'm switching between those two things, and everything's going to be slow. So, again, think of the model where you have like a really wide freeway and that converges into like a single lane, right? All these 10 cars, they're not going to be moving very fast. It might be easier to have like a single lane and everything is now flowing rather than having to have this converging thing. So this work in process, again, think of the factory analogy. If you make stuff that is sitting on the bottleneck, they'll move it around because it's literally like they'll move it around because they don't have space in where it's at. So the software equivalent is you have a PR and it just sits there. And then when it's time to merge it, you can't do it because it's too old and it needs rebasing and you don't know what it's at. So you might throw it away. So that's work that was just completely wasted and it didn't do any good. It decays, it rusts if you want to keep the factory analogy going. So a lot of times my advice to companies for this common mistake is pull back a bit, right? Focus on shipping. Instead of starting so many things, focus on finishing that many things. And when you finish one, you can pick another one. So for features, this could look like we only are doing like X things at once. Pick your number, 3, 5. It's not 50. And your pile can be up to this big. And when when you're done with this, when you're done with, if you have 5, when you're done with one of them, you can put a new one in the pile and go from there. And by the way, you can apply this to other things. Like you can say bugs. When bugs go over a certain number, we stop building features and we bring down the bugs. And if this number is 50, then that means you're always going to have 50 bugs. The number of bugs going in, the number of bugs going out needs to be the same. Otherwise, it goes more than 50. So if you pick a number that's 5, still the number going in and the number going out are the same, but now there's fewer bugs that your customers have to deal with. So think about how you prioritize bugs and how many bugs you want to have around and how that affects the experience. So technical debt, trying too many things are two of the most common ones that I see. The visualization of work is very common. People don't visualize how much work they have, so they end up having too much of it. That's the 3 most common. I have many more, and I can talk for hours about these.
Okay. Nowadays, any conversation has to have AI in it. Now, does vibe coding make it easy to address some of these things, or does it add to more confusion?
I'm going to start with definitions. So, vibe coding, as defined by Andrej Karpathy a while back, is when you not look at the code. So, if you just tell the AI what to do, and it just keeps going. And vibe coding is a terrible idea. You can do it if you're playing around. You can do it if you want to prototype something. But if you're planning to ship something, vibe coding is not going to work. Please, please don't. Now, what most people talk about when they talk about AI coding is a bit more of a mixture where you have the AI write the code, but then you're looking at the code. You're not like just spewing out whatever comes out of that. And I think for me, that is obviously the future. There are good ways of doing this, and there's bad ways of doing this, and there's everything in between. And we're still discovering how some of these ways of doing this work. But I think the AI, I call it the AI, like the Google, as the LLMs and the systems I'm going to call the AI are really good at certain things. And I think if we leverage them just right, It can massively increase the individual developer productivity. I've been using these tools for the past several months now, and I am at least 2 or 3 or 4 times faster in shipping up any feature. Um, to do this, I think there's two things that you need to have in place. The one is you need to have the right systems and prompts and mechanisms for the individual engineer to work with the AI. So I've developed my own over time. It's along the lines of give me really small changes. I want to be able to understand these changes. Don't give me something really big. If the AI does give you something big or you don't understand, you can just push back and say, no, 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 this is not what I want. Start over. And this takes a little more time. But I found that if you makes a big change and you kind of think, this probably works and you accept it, you're going to get in trouble like 5 minutes later. So like take the few extra seconds to correct it and deal with it and make sure you understand every single line that it writes. If you don't, you're going to be in a world of hurt. So we shift, right? We being from instead of being the code typers and figuring out like how does this API need to get called, the AI can do this for you, but you need to be the manager. You need to understand the architecture and the structure and the patterns and how are you going to test this code, and you can be the um, guide of the AI to get it to go in the right place. So I think if you do that, you can be very productive as an individual engineer. But then comes part two, right? Which is even if I become the world's most productive engineer, the systems and the basics that we need to have in place around this, all this stuff we've been talking about from the beginning of the podcast, still need to be in place for the system to work. If you don't have good testing infrastructure, if you don't have good CI/CD pipelines, if your business management doesn't understand, you need to have tech debt time to fix previous things. If you don't have good collaboration with your product team, you can have an engineer that writes a silly amount of code, but then they have a way of no deploying it. They have no way of socializing with others. They have no way of knowing and solving the right problems and the right features. So I think good engineering becomes much, much more important now that we're using the AI. Essentially, think of it as before, the bottleneck might have been the engineer that was writing code because that was slow. But now the bottleneck has shifted. Assuming you're doing this right, the bottleneck shifts and it moves somewhere else. And this somewhere else might depend on where your company is at, where your team is at, but it's somewhere very, very different. Now you got to solve that. And the problems have been the same for the last 20 years that you need to go solve to do that.
Yeah, I think to address this, we need a lot more Thanos. So, any thoughts on kind of scaling Thanos or cloning Thanos using
I've
tools
had many
or
thoughts.
encapsulating your knowledge and experience?
Yeah, I think it's kind of tricky. So I'm trying to do my part in doing this. I have some resources on my website that sort of go through some of these, and I'm trying to kind of communicate these as making software better, right? Like I think the software engineering industry is in many ways like in a little bit of a mess. Like if you go to any of the big companies that are a little dysfunctional, this is not how we should be doing software. Like people are like burning out and people are going through a lot of pain to deliver to their end users unnecessarily. So I'm trying to put out like some resources and thinking and my writing on my blog and other places that kind of go through some of these things. Um, yeah, I'm not building the Thanos AI yet. I don't think that has legs yet. I think that's still kind of a bit early for something like that to be productive. But one of the things I've been thinking of, and when you're hearing this podcast, look me up. I might have done it by then. Is putting together, what's like in 1 hour. What are the basic things you need to do to get like an AI coding thing functioning properly? What are the right tools? What are the right processes? And be like a primer in, okay, here's like how to nail the basics and get those ideas out. I think I just concocted that a few days ago, and I think that might be fun to go do.
Yeah, we'll include a reference to your website in the show notes for sure. Okay. Yeah, I didn't realize how long we've been talking, but then there's at least a couple of more things that I'm curious about.
Time flies when you're having fun.
Yeah. I read that you have fun other ways too. As a pilot, and you ski and you kite surf. How do you manage all this? How do
Oh,
you
so
find time? Yeah.
yeah, when I left my full-time job, I didn't have a specific alternate plan at the time. So I spent a little bit of time thinking of what I want to do. And one of the things I figured out is I didn't actually want another full-time job.
Mm.
Now, there is a joke that says if you work for yourself, that's great because you can choose which 24 hours a day you're working. And that part of it is slightly true.
Mm.
But one of the things I figured out is I actually value my leisure time. I have two kids. They're 11 and 14, and the one is heading to boarding school, so he's going to be out of the house soon. And I want to be able to spend time with the kids and be able to go to their games and not have to ask my boss of, hey, I need to take off at 2 for like 2 hours and do this sort of thing. So the idea of doing this as a coaching business and a fractional CTO business was coming out from the idea that I want to be able to manage my time and be able to do things that I enjoy at the same time of this, and still be able to deliver value to the people that I work with in a good way. So by having multiple clients, and now I can work at my own schedule, which is really nice. I usually will take off in April and November and go kite surfing with a bunch of friends in South Texas, and I'm heading out on Saturday to Greece for 2 months, where my schedule is going to be kite surfing in the mornings and then working in the evenings. The evenings in Greece align with U.S. time, so that's a lot of fun. And you can have kind of a nice schedule, and you kind of like working. It's like a workation, right? You're working, but you're on vacation. I enjoy my work, so it's not like I finish kiting and it's like, oh, now I have to go to work. It's like, okay, cool. Now we can get to go solve some interesting problems with some interesting people.
So maybe the next question that comes to my mind already has been answered, which is about how do you stay grounded? When you have so many things going on and each one spinning at its own speed.
Yeah, one of the realizations that I had with this is I would get really caught up. My identity would get caught up in my work, and I would very much identify with it. And it goes beyond wanting to do a good job. It's like it becomes sort of part of you. And one of the things that popped into me, and this is, you can read this in two ways, and I don't want you to read it in both ways because one of the, you'll see what I mean. But sometimes a job is just a job, right? And you don't want to burn yourself out or make personal sacrifices that are like way above and beyond ruin relationships because of a job. Like I look back at jobs that I had, and many of the jobs that I had, the companies don't exist anymore. So it's like, okay, we did some cool things, we built some fun stuff, we delivered some value, but like, had I gotten like divorced over that job, where did that get me? Like probably nothing, right? So I don't want to take this the wrong way that like you don't want to care about your job and it's just, oh, it's just another job. I just go show up, do my thing. Like I actually really enjoy doing those and I want to do a good job and want to be in it. But I also recognize that's one part of me, right? That's one aspect of me. And there's another aspect of me that, my personal life, my relationships, my children, the things that I do for fun for myself, that is just as important. So I try to now look at it and go, okay, you know what? Like, I really would have liked to get this feature out today, but like, I have to go to this dinner, and it sucks that this feature is going to have to go out tomorrow, and that customer may not be as pleased, but that's the right balance for today. Obviously you try to put the systems in place so that doesn't happen, right? Because you want to plan correctly and not make these things happen. And maybe there are some times where you might actually cancel dinner and go do that thing because that's like the really important thing. But like being explicit about it and finding your own balances and being thoughtful about it is what I found to be useful there, and sort of making better trade-offs than I maybe made 20 years ago.
Okay. But you make it sound easy.
It's not.
I know.
I think these things are always like, you try and you fail and you try again and you fail and you try, and you try not to be too hard on yourself for failing, and you just keep having at it.
So on that note, Thanos, thanks a lot for sharing a lot of very insightful and thought-triggering experiences and your perspectives. I'm sure our audience will find it very useful, particularly the way, without using the term Kanban, you kind of brought in flow, you kind of brought in bottlenecks, and you said how things can be better in the software delivery lifecycle. Thank you.
Thank you for having me on. Time flies. We went for an hour and just went like this.
We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.